Welcome everyone to another video in which we are going to solve problem number 14 from chapter number 2, force vectors in the book of Engineering Mechanics, the Aesthetics part by R.C. Hubler. This video is available with audio tracks in different languages, mainly Spanish, French, Portuguese, Hindi, Japanese, Indonesian, and German language. If you want to listen to any of these languages, just go to right bottom of this video where you will find the setting button. On clicking setting button, you can find the audio tracks and then you can accordingly change the language of your preference. So in this problem, we are being asked to determine the magnitude of force F which is acting on rope A and also its angle theta, and we are being given that the resultant force caused by these two forces, 900-pound force and F force, is directed horizontally to the right. It means the resultant would be in this direction. So let's start solving this problem considering the body on which these forces are acting. So as I told you that the resultant would be directed horizontally on the right and has a magnitude of 1200 pounds. So F force is required and also the theta angle is required. Now in this problem, I'm not going to use sine law or cosine law to determine the magnitude of the force F and its direction. But in this problem, I'm actually going to use the concept of resolution and composition of the forces. Whenever I'm saying composition, it means determining the resultant of the multiple forces. In this case, it's only two. And when I'm saying resolution of forces, it means if one force will be converted into multiple forces, usually the two forces, which is in the form of rectangular components. I'm not going into the detail of that because I believe that's the basics of the resolution and composition of forces. So you would be having understanding to that. But if you feel there is something which you cannot understand, then please let me know through the comment section so that I can get back to you. So in this type of method, the forces should be resolved into its component. In this case, it will be the rectangular components. And then using the formula of composition of forces, we can determine the magnitude of the unknown force. So rectangular components of F force will be in the direction of X and in the direction of Y. Similarly, the rectangular component of 900 pounds will be in the direction of X and in the direction of Y. So now I'm going to use a formula which is the composition of force. It means the determination of the resultant force. So this can be determined if we know the magnitude of X component of the resultant force and the magnitude of the Y component of the resultant force. Both should be with the help of square. Now, how this FRX will be determined and how the FRY will be determined. First of all, the components of F would be like Fx, which will be here, and Fy, that will be over here. Similarly, the direction of the horizontal component of 900 pounds force will be this direction, and the Y component will be in this direction. So FRX is actually the addition of all the X components which are forming this resultant. So there are two forces here. So addition of these means Fx plus the X component of a 900 pounds force. So the X component is usually calculated as 900, the magnitude, multiplied by cos of angle which is this force making with the horizontal axis. In this case, it's not directly given, but we can determine this will be the angle and that will be 30 since this is 60. So cos 30 then. Similarly, the Y component will be Fy, this one, since it's directed upwards, so it should be positive, and in this case it should be negative since it is downward direction. So 900 multiplied by cos, not cos in this case, but it will be sine in this case, sine 30. Now how about the X component of the resultant force and Y component of the resultant force, since the magnitude of the resultant force is directly given? Since the force is directed towards the positive Y axis, That's why all of its magnitude will be the x component of the resultant, and since it's directed towards x, it will not be having any y component, so 0. So this 200 then will be equal to f of x plus, now if you solve this, this will be equal to 779.4. So from here you will have f of x as minus 420.6, and from here you will have f of y, this will be 450. So then f of y would be equal to 450 pounds. So now you can use the formula, this formula I'm talking about, the composition of forces. So then F would be equal to in the under root f of x square plus f of y square. So f of x and f of y, we have those values, 450 square and 420.6 square. So on solving this, you are going to get the value of f as 615.94 pounds. I made a slight mistake here. It will not be actually minus, but it should be plus. Both are positive values. Now determining theta is quite simple. You can use tan theta formula, which is f of y divided by f of x. F of y is 450 divided by 420.6. So from here you will have theta, and on doing calculations you are going to get theta as 46.9 degrees. So now we have got both the answers that was asked to us. So this is how you can use the resolution of force vectors and composition of the force vectors in order to determine this kind of problem. Whatever problems we have solved so far related to the determination of the resultant force and all, you can use this concept in solving all those problems. So that's all from this video. I believe I tried my level best to let you know how these kind of problems are being solved when we are being asked to determine magnitude as well as the direction of one force. If the resultant of the two forces is given and also its direction is given. So this is how we can solve these kind of problems. That's all from this video. I hope to see you in next coming videos. Till then, bye.